Hello, and we're going to be doing a LeetCode medium problem, validate binary search tree. Given the root of a binary tree, determine if it's a valid BST. What is a BST? Well, the node on the left has to be less than the parent node, and the node on the right has to be greater than the parent node. So this would be true, this would be a BST because 1 is less than 2 and 3 is greater than 2. But this would not be a valid BST because 4 is less than 5 when it should be greater because it's on the right. So you could do minimax, you could do some sort of DFS, but I think it's a bit inefficient. So what I would do instead is I'd do an in-order traversal, which basically looks at the left subtree, then the current subtree, then the right subtree. This would mean that for a BST, it would generate a monotonically increasing sequence of numbers going from left to right. But instead of having to check if each and all the numbers are greater than the ones before it, we can simply just check for falseness by seeing if one value is actually less than the previous value. If that's the case, then we know that it's not a BST and we can just return false. For instance, if this was 0, this would be the current value, this would be the previous value. So we can just say that this is less than that, so then we know it's a false binary search tree. So we can do this iteratively or recursively, but I'll show you both. So let's have a private integer called previous, which tracks down what the previous value is. And then we'll just say previous is equal to null to begin with. And then we're just going to say return in order traversal of root. This is going to be a function that we write up here. So then we just say private boolean function called in order traversal, which takes in a node. Then we look at the base case. The empty tree, or we get to the end, a null tree, is a valid binary search tree by default. So we can say that our indivisible case, this is true. Okay. Otherwise, we've checked it's not null, so then we just check what we look at the left hand side first. So then we just say if this on the left hand side is false, we just return false. Okay, otherwise we check, okay, if previous is non-null and we see that root's value is less than previous, then we just say that we return false. Like I said, by the time we get to this point, we have 1 set to the previous, so we're checking the parent's value against this value. Since we're looking at the left-hand side, we know that it's always going to be greater if it's a binary search tree. If it isn't, then we know that it is not a binary search tree. Okay, so otherwise we've made it past this point. We're either at the bottom of a tree or we're at the top and it is valid. So then we just set the previous value to equal the root's value, and then just return in order traversal on the right hand side and just recurse down that right hand side. Okay, so let's explain what's going on here by doing a quick example, because it is rather abstract what we've done. So let's just explain by putting in a function. I'm going to say IOT for short for in order traversal. Okay, so we're starting by putting in 2, which is our root. We haven't found the answer to this yet because we have to first check what 2 is saying. So 2 is not null, so we skip the first if statement. Then we have to check IOT1 because we're having to recurse down the left hand side. So let's put that on hold for a bit and check what IOT1 is because we have recursing down this side. So 1 is not null, so skip the first if statement again. Now bearing in mind at this point previous is still set to null, right? So we can just say we check the left hand side of 1, which we know is true because 1's left hand side is true. So 1.left is true because that's null. So then we've skipped past the second if, and then we're looking at the third if. Well, previous is still equal to null because we're at the bottom, so previous is null, so skip third if. Okay, so we've made it to this point here. We've checked against everything. We know that this is the case. So then we just set previous to equal to 1, and we return what we return io1.right. Okay, 1.right is true. So then we know that IOT1 is true. So we know that IoT's left-hand side is equal to true. So we know that's true. So we skip the second if statement. So then we check against what previous is. Well, previous is now equal to 1. And so that's now not null. And we know that 2 is greater than 1, right? So we're not in the position where we can skip the third if statement because we know that we're greater than 1. So this is the case. So then we can just say that the previous value is now equal to 2, and then we want to return 2.write, which is free, IoT free. So then all that we're hinging on right now is we're returning what the value of IoT free is. We need to see what the right side is saying before we can say if it's true or not. We know by virtue of this if statement that we wrote before that the left hand side is true. So the only thing that's stopping the IoT2 from being true right now is if IoT free is false. So what is IoT free? IoT free, so we know free is not null. So we skip the first if statement. So then we check against free.left, which we know is true because free.left is null. We then check what previous is. Previous is 2 from the previous section because we've just passed it in again. So we know that we're checking against 2. 2 is not null. And 3 is greater than 2, so we skip the third if statement. And then we just return free.write, which is true. So we know that this is true, which means that IoT2 is true, which means that it is a valid binary search tree. Okay, so that makes sense for this example, but what about for this example? Okay. So we do IoT of 5. So we do IoT of 5. 5 is not null, so we skip the first if statement. We then check 5 on the left. So check IoT of 1. So now we're checking IoT of 1. We'll set this to pending because this is now somewhere below the call stack. So we're looking at IoT of 1 now because we're checking 5's left-hand side. So 1 is not null. So let's bear in mind that previous is still equal to null from instantiating at the start. 1 is not null, right? So we skip the first if statement. We then check 1.left, which is IoT null. This is true. So we know that 1.left is equal to true. So then we're waiting on 1.write. So we know that previous is still equal to null, so we skip the third if statement. And then we're just going to set previous equal to 1 because we've made it through this entire section. So we know that it's true so far. We've gotten to the child. So we then say, what is IoT of 1.write? That's going to be null, so this is true. So then we work our way up. We know that 1.write is true. We know that 1.left is true. So we know that IoT1 is true. So we know that this is equal to true. So then we skip the second if statement. So what are we doing now? So we've checked left, the left-hand side is true. So then we're going to be saying, we know that previous is now equal to 1. So we can just say that 1 is non-null because previous is not null. And we know that 5 is greater than 1. So we skip the third if statement. Previous then gets set to 5. Check what IoT of 4 is. So we know that IoT1 is true. Awaiting IoT4. So now we're looking at IoT4. And we know what previous is. We know previous is equal to 5 because we did that from the previous iteration. So 4 is not null. So we skip the first if statement. We then say what IoT of 3 is. IoT of 3, well, we know that's going to be true. I'll skip that whole section because we know that we're just going to be checking it and it's true, 3 and 2. So 3 null, 3.left is null, 3.right is null, so we know that previous is now equal to 3 in IoT of 3. We know that 6 is equal to true as well because we've gone through that section, so we know that previous is equal to 6. We're going through 6. Previous is equal to 4 in this case. So we then go through the entirety of that section and we know that IoT of 4 is true. So then we go through IoT of 4. We then check against the right hand side. So got myself a little bit lost here. So I've checked what IoT of 4 is. The previous value is equal to 5. So I've gone through 3. I've checked that 3 is true. So then I look at 4. So I look at 4. Previous value is equal to 5. So 5 is not null. And 4 is less than or equal to 5. Meaning that this is false. So we return false. IoT of 4 is equal to false. So if that's false, which means the whole tree is false. This will work if we run it, and if we submit it.